It was 11 o'clock at night and I was about to throw my computer out the window. I'd spent the last several hours trying to figure out this issue in Python and absolutely nothing was working. I'd been defeated by hours of looking up on Google and Stack Overflow, and with one final snapshot of my laptop, I was done. I was defeated. It was over. But then the next day, the sun rose and something magical happened. I was actually able to find the issue and proceed with my day. These 3 skills, which actually took me about 5 years to learn, absolutely changed the way that I was able to do modern GIS and geospatial analytics. And the first skill within that is actually understanding how to debug and understand errors when you're programming. This is one area where I see a lot of people get tied up. They're working on a project and suddenly an error pops up, they see it and they don't exactly know what to do with it. It can be where a lot of people get stuck and honestly even give up when they're doing this, just like I did when I mentioned earlier. But errors are clues. They are details into what's happening, and they can actually help us understand what's going on, and knowing how to use them and the different pieces and tools and clues that you get can help you become a better programmer. First of all, you have to read your error in details. When you identify the error, it can give you a lot of clues on what's actually going on, and those clues can help you figure out what you need to do next. Once you've seen those clues a few times, you can actually become a lot more efficient when you're programming, and it's actually a really good learning opportunity to help you understand in the future what's going on and really understand the dynamics of what's happening during the programming that you're doing. So there's a few different errors you might encounter when you're working in programming. Primarily, we'll talk about Python and SQL, but the first is syntax errors, which is basically an error. There might be a missing element or something that basically prevents the code from running. There's also runtime errors. Basically, this could be anything like dividing from 0 or trying to access an index that's out of bounds. You also have logical errors. If you're running a loop and there's some sort of condition that's not met or not accounted for in the loop, you'll also get an error that way. The good news is there's lots of tools to help you do this. If you're using an IDE or a programming tool like VS Code, there's different tools that will actually help you debug within that program with plugins and other things like that. I also recommend implementing code reviews, even if it's just you personally reading through the code and seeing what's going on and making sure that's logically what you want to do can be a great help and help you reduce errors that might come up later on. Now, for some practical tips when you're working through debugging errors, the first is to stay calm. Everyone encounters errors all the time. This isn't new. Everyone writing code hits errors. It's not just you, it happens all the time. The second is, once you've learned about the error, try to understand what it is. You can look that up and Google it, use different resources that you might find either on Google, Stack Overflow, or ChatGPT as well. We'll talk more about that in a minute. The next tip is to make incremental changes. Make a small change to see what's going on and try to go bit by bit. You can use the technique of rubber ducking, which is basically talking to yourself out loud to try to figure out what's going on and see as you make those changes what makes sense and eventually get to the bottom of the issue. The next bit is also add documentation. Keep some notes in your code so you know what's going on where, so if you need to come back to it, it's really easy to understand and read. You also don't have to struggle alone. Like I mentioned, there's great resources out there, including documentation. Some common libraries like GeoPandas actually have sections in the code that document common errors and how to get around them. So there are other resources outside of just Google and Stack Overflow, which you can reach out to depending on the code that you're writing. And that brings me to my second point, which is reading documentation. Documentation is the ultimate source of truth for anything that you're doing. It's written by the people that create these tools, and it's very, very detailed. That can be a positive and a negative. Sometimes there's so much information that's overwhelming, and there is a specific way to read what's happening in that. So let's break apart documentation to help you understand what's going on. There's 3 advantages to really being able to work through documentation. First, like I mentioned, it's the ultimate source of truth. This is telling you exactly what's going on, and it's from the people that have created the tools you're using. The second point is self-sufficiency. If you can read documentation effectively and use it and then execute that in your programming, you'll become a much more self-sustained and self-sufficient programmer. And on the same point, you can become more efficient as well, finding an issue, reading it, or learning about a new tool and implementing it quite quickly. Now, as for documentation itself, there's also multiple parts of documentation that you might want to know. First of all, there's official documentation, which will actually describe what the tool is and what it's doing, and maybe provide some context around that as well. There are also generally API references. So an API reference will tell you what a function is, exactly what it does, the arguments that go into it, and some expected outputs. So it's very clear about this does this comes out, things like that. Generally, most documentation includes tutorials and guides. These are official guides that are written by those same authors of the documentation that actually help you determine what you should do with that and help you guide and learn that tool as well. In many cases as well, there's user guides and community forums that you can use to actually interact with individuals or see if a question has been asked before and try and implement it yourself based on your issue that you're seeing. Now, all documentation is different. If you look at PostGIS documentation versus GeoPandas documentation, they all have slightly different flavors, so you have to adjust for that. But being able to read the documentation and understand it is really important. I actually broke that down in my book on Spatial Spatial SQL, there's a section here that you can see now talking about how to read the documentation for PostGIS. It's very specific, but once you know how to use it, you'll be that much more self-sufficient in the future. Now, my tips and tricks for reading documentation: first, make use of the tutorials. As you start to read the tutorials, that'll get you a sense of the flavor of the documentation that's being written and help you understand what's going on within those docs itself. As much as you can, use examples and actually try to implement that. If you're doing something in a tutorial, read back to that specific thing. Oftentimes these are linked together anyways, so if you're implementing a intersection function within GeoPandas, you can usually click back to that. If you're working in it from a tutorial, see the actual function reference and then look back at that, what's happening there. And then finally, using the API references, those are the actual function calls. A lot of the time you're actually going to find, if you're trying to do something with a function, it's already been implemented. If you have a problem, someone else has probably had it too. So go there and see if there's an option to actually use that. Sometimes it's not shown in all the documentation like in the examples, but there might be a specific parameter that, this is exactly what I need. You can see it there and then use it right away. This has happened to me plenty of times with functions in SQL and Python. There's usually, if I have a problem, someone else has had it too, and you can actually check it out there. My two other tips is to always cross-reference. My other tip is to actually test out and experiment. If you see something, try it, see if it works. If it doesn't, worst case, you spent a little bit of time doing that, but you've tried and maybe narrowed down what you're trying to do a little bit further. Now, reading errors and using official documentation is incredibly important, and I don't think anything else exemplifies this as much as building the Airbus A380. This is when they were building a new model of this plane, and basically parts weren't starting to fit together, and they had to read through errors and documentation, and basically figured out that they used two different versions that are incompatible of the same software. So they were building on two different systems and kind of had to start over. Now, once they figured this out, they were able to fix the issue and go ahead and get that plane off, flying in 2005. But using docs and debugging is incredibly important, and you might find it might be the smallest error, just like they had at Airbus, that might be causing an issue, but getting down to that and doing that self-proficiently is a really valuable skill as a programmer. Now, my third tip is really important, and this is the one that you might not want to hear, but we're going to talk about practice.
I mean, listen, we're talking about practice.
Practice is incredibly important. I oftentimes move between different projects and languages and wanted to just jump in and figure things out. And ultimately I would hit some sort of error or issue and maybe put that project off and jumping it through. So actually going through the process of seeing something all the way through, even setting up some scenarios for yourself to try to figure these issues out, is really important. You need to go through the diligence of doing this over and over, and putting in that time and that effort will help make you a better programmer and ultimately more self-sufficient. That's the key here. You want to get as self-sufficient as possible so you're not relying on things or questions or just getting stuck and dropping it all together. So how do you do this practice? I think setting a tangible goal of a project you want to accomplish and setting apart some time to actually do that is your first step. Pick something you want to do that's particularly challenging and try and do it and work it all the way through. Now, start with small projects that are achievable in a specific time frame and work your way up to bigger projects, or break that big project into smaller parts. I would also recommend doing a code review. Make sure you leave yourself notes. I mentioned that earlier, but the more information you have, especially if you're going to come back to something later, will really help you understand what you were trying to do and what that was actually happening. Now, one of the most important things when you're practicing is creating a consistent workflow for yourself. If you're practicing something, you want to get consistently good at it, and having a workflow that you can fall back to anytime you have an error is incredibly important. So imagine an error pops up, what's the first thing that you do? An example of this could look like, I'm going to go Google the error, see what's happening. Maybe I refer directly to the documentation and see if it's there. If that doesn't work, I read the error code in detail and see if I can figure it out from there, or trace it back to figure out where the root cause of that problem was. Once I've figured that out, I can actually test that out, see what I need to change in my code, either upstream or within the function itself. Try to resolve that error and then keep testing and going from there. Having that workflow and having it as almost muscle memory will really help you become more proficient. It's practice. We're just trying to figure this out and make ourselves better at it. There's lots of examples of real world scenarios of this. There's another example in my book, which you can see here, which is basically trying to read a data type, and you can see this error here that's incompatible and not working. And ultimately, spoiler alert, the answer for this one is you just need to change the data type. It's reading a different data type that is not compatible for the greater than or less than measurement. Change the data type, resolve the issue. Now, another common one is invalid geometries. I've seen this one happen all the time, either overlapping parts or other parts like that. And figuring out how to validate your geometries is a specific problem for geospatial, but one that's incredibly important to note. And then the last one is within Python. Now, Python errors can be a little bit tricky. They can almost show you within a library all the steps all the way back to the base code that it's writing. So sometimes you get these errors that have multiple steps. You see this references line this, line this, line this. Being able to read that whole, it's called like a stack trace log of all these the issues that are happening is really important, and figure out the actual thing that's taking place. Sometimes these are very descriptive, sometimes they're not. But reading through this error and getting to the problem like you see here, here's the actual issue I'm facing, can help you a lot to figure out, oh, this is something I wrote wrong in my code, or I have a malformed function, and it's just hidden and buried a little bit, but it'll help you get to the bottom of the issue much faster. Now, the good news is we exist in an age of AI, and ChatGPT can be incredibly helpful for you. I actually asked ChatGPT to give me some tips on how to provide it for debugging, and here's what I got back. As you can see, it's really amazing to have all these tools at your fingertips to basically access a complete wealth of knowledge without having to Google and search and go through endless Stack Overflow posts. And you can actually use these same tools to learn new languages and skills. I've done that in this video up here. You can check that out. It's actually learning geospatial Python with the help of our friend ChatGPT. So I recommend you check that out over here.